So for long division, we're starting to learn how to divide. There's two different ways to do it. Today we're going to focus on long division. Monday is synthetic. And then after that, all we have left to talk about is factoring, believe it or not. And then we're done with this chapter. So most of next week, especially Thursday and Friday, the 10th and the 11th, we're going to be reviewing for your test, which is going to fall, unfortunately, on the 14th, which is a Monday. But also next week, we're going to start working on getting reviewing for your final and getting that ready to go too. Your final, you have a two-piece final. The 16th will be the 10 questions that you just do. So I give you 10 questions that covered material over the course of the semester. You have, class time, 47 minutes to do it. Done. No, it's not open notes. Right, but I am making a study guide to help you with the 10 questions. If you do your study guide, you'll know what to do. No, but you have to remember some stuff from previous chapters. And then the 17th is going to be the multiple choice part, and that's just ACT style. So that one's going to get curved, though. Yep, curved. Okay, so first things first. Can we take a polynomial and divide it by a monomial? Because remember, that's one term. And so the answer to that is yes. So what we can do is we can rewrite each term being divided by 3ab. So I'm taking each piece of the polynomial and dividing it by 3ab. Okay? So if you're dividing by a single piece, a single polynomial, which is a monomial, then we just write it like this, and then we just do the problem. And it's just like little problems like we had before with the division. So if I look at this first one here, what can I cancel? So I can cancel 1a, the b's I heard, and the 3's, right. So all I have left is a plus, now I'm going to go to the next little fraction. So I can cancel 1a, so I'll have 2 a's left. I can cancel 1b, so there'll be 1b left. And then, of course, 3 and 6 go into each other, so then this would just become 2, because remember, 6 divided by 3 is 2. So then I have 2a squared b. Why 6? Right, 18 divided by 3 is 6, and then the a's and b's, what happens there? They cancel. And so technically the only thing that would probably be a little bit of finesse thing would probably be to do this. Because remember how we like to put polynomials in descending order. So I want the highest number of a's first and so forth. But if you wrote it like this, I don't think I would necessarily be awful with that. So questions about that one? Okay, so the next one, same idea. So nothing's going to change. So we have only 2 pieces this time, and both of those pieces get divided by 3x. So now again, let's look at our first part of the problem that we have to reduce. So what can I cancel? So I can cancel an x, so there'll be 1x left in the numerator. And 3 goes into 12 4 times. Yes, so we'll have a 4xy. And then what's going to happen here with that next term? So the universal people always like to fight over, is this 1? Is it 0? What is it? It's 1. Because, again, anything divided by itself is always 1. So, and the y is because the x's cancel, and 3 goes into 3 once. So 3 divided by 3 is 1. So it can't be 0 or there wouldn't be anything there. So that's my answer. So questions about taking a polynomial, dividing by a monomial. Okay, next step. So now this part is usually the easier part, and you're going to have 4 problems like that. And then the second part is doing what we call long division. And so you can solve this. You're going to take a polynomial and divide it by a binomial. And so to do that, we can do 2 techniques. We can either do synthetic division or we can do long division. And so today's long division. So before we do that, you have to kind of regress a little bit. Do you remember what you were like as a 4th grader? No? Okay, so we're going to kind of go back into 4th grade math here. Okay? All right. Okay. Long division, 4th grade math. That's a 163. Okay, so back in the day, remember, how would you start thinking with the 2 and this? So like 2 times what is 16, which is 8. Then what? Right, we multiply down to make 16, and then what? Right, we subtract, and then which is 0, and then, yep, we bring down the 3. Okay, 1 times 2 is 2. Well, technically, we could say in 4th grade, you would have just said remainder 1. Or later on, you learned how this is just really 1 over 2 because that's what you divided by. Remember that? We're not going to do the decimals because we're not going to do decimals with this. So I don't even want to bother. So this is math even before decimals because in 4th grade, you don't do decimals yet at that point. No, we're going to put, I'll show you. So in this case, like a 4th grader would, yes, write remainder 1. So like if this was Alexa's class and Mr. Laufenberg's down in Parkview, that's what they would do. Okay, but what we're going to be doing, this is going to be similar to polynomial. So I'm trying to keep it pretty consistent so you can see the parallels between that math and this math.
So I did it different. I do it in my head. So take 160 divided by 2, that'd be 80.
Yep.
162 divided by 1 and then.
You did that in 4th grade?
No, I did that in my head right now.
Yes. So yeah, so that's kind of like breaking it apart using the distributive method and breaking it apart kind of factoring-esque. So yes. So how do I use this now with polynomials? So you make a big long division. And so the first thing is what we're dividing by. So that's going to go underneath. And then what I'm going to divide by is going to go outside. Just like on here, I was dividing by 2. So it's going to look similar to this, except it's got letters. It's not really. Okay. So what we're going to do is we're going to focus on, remember how we focused on the 16? Here we're going to focus on m squared. And you don't have to worry about what's with it. Just focus on the first piece. Okay? So what would I need to multiply m by to make m squared? M. Okay? So that's just m. Okay, because m times what makes m squared? M. Okay, but then remember how we had the 8 up here? Then what did we do? We multiplied it down to make the 16. So we're going to do the same thing. So what's m times m? Okay, but I also have to account for this 2 here. So now I have to do what's m times 2. Right, and that's a plus 2m. Okay, so I had to multiply what we came up with to both the m and the 2. Okay, now we're here. So then what do we do after here? We subtract it. Okay, now I'm going to subtract. The m squares will drop out because you made that term happen. So now we just have to figure out what's negative 3m minus 2m. Be careful. Negative 3 minus 2. Negative 5. And then some of you guys said, yes, bring down the next number. I did. So I brought down the negative 7, just like here, I brought down the 3. Except those two are not like terms, so that's why I got to keep the sign. Mm-hmm. Yep. Okay, next. So now we want m to make this. So what do I need to multiply m by to make a negative 5m?
Negative 5.
Okay. Okay. And then multiply down. So negative 5 times m is negative 5m. And negative 5 times 2 is negative 10. And then again, I'm subtracting, just like what I was doing here. And so here we're going to have, yes, negative 7 minus negative 10, which becomes plus 10. I agree with Ron, it's 3.
Oh, I said 3.
Oh, sorry, Ben, you said 3. So then my remainder is 3. So I don't want to write R3, but what we're going to do is, first of all, is the remainder positive or negative? So you're going to use a plus sign. If it was a negative remainder, then we put a minus sign. So I'm going to put a plus sign after the 5. And then I'm going to write 3, because that was my remainder. And then what do you think is going to go underneath of my fraction? Yeah, it's going to be m plus 2. So there it is. We figured out what m times what will make negative 5m. And so we figured out we already had the m, but we need the negative 5. And so that's why we put a negative 5 up there. So yeah, so we're trying to find the factors for that. If you notice when you do the square technique, because some of you guys said you do the square technique, there is another way to do the division if you like doing the box technique. So, and that's one that Mr. Tesh just shared with me this morning. I didn't have a lot of time to look at it yet, but I did put it online in case some of you guys are interested with a different technique. So, but I just want to focus on long division today. Okay, all right, here's another one. We're going to do 2 more, and then I'm going to have you try it. So for 4, again, the same thing we're going to do, put the big polynomial underneath. Yep. So when you're doing this, am I going to give you a lot of problems like these? No, because again, they're a little bit more, time conducive for that. So we're going to be dividing that by x minus 2. I will show again another way to do this on Monday, which is called synthetic, that eventually some of you guys will decide probably one way over the other. Just that in pre-calc, it's nice to know both. So same thing in calc. It's nice to kind of know the different styles. So yes, how do we figure that out? So we're looking at the x. We're thinking, okay, what can I multiply x by to make a 3x cubed? Or it's kind of like thinking about a box. So like, remember how in the box this is x minus 2, and in the box is 3x cubed, and you say, okay, what would I put up here that would make 3x cubed, which would be 3x squared? So that's what I'm talking about with this box method, that there's a video that Mr. Tesh found that was actually kind of cool. No. So, and then if you would complete the Punnett square, then you would be there. You'd be at negative 6x squared, but we'll get to that in a little bit. Okay, so then I'm going to multiply down. So we're going to have 3x cubed minus 6x squared. We're going to really end up with negative 8 minus negative 6, so that's negative 8 plus 6. So we have negative 2x squared. Okay, so now what we have to do is figure out, and I'll show you what that looks like on the Punnett square. So now I've got x minus 2. I'm just focusing on the x. What do I need to multiply? Oops, I forgot to bring down the next term. Lo siento. So we have to bring down the plus 5x. And then, okay, why do we need to multiply by negative 2x? No, I'm not going to bring down the negative 1. I will in a little bit, because we're only going to bring down one at a time. So we're going to multiply by negative 2x. Why? Well, because if you go back to this square, okay, to help you, see how this is negative 6x squared? What do I need to make negative 8x squared? I would need this to be a negative 2x squared, right? Because negative 2x squared and negative 6x squared would make negative 8x squared. So then that tells me from this box, I need a negative 2x. Because see, negative 2x times x would be negative 2x squared. So multiply down, we'll get negative 2x squared plus 4x. Again, we're going to subtract. Our x squareds are going to drop. And then what's 5x minus 4x? 1x. CPM. Bring down the minus 1 that Paloma talked about before. Okay, now what do I multiply x by to make x? So this is going to make a 4x here. So, right, so you have to think about what do I have to add to the 4x to make 5x? This is going to have to be a 1x. So we needed to multiply by 1. So therefore, this is going to be a plus 1. And then 1 times x is x. 1 times negative 2 is negative 2. Subtract. The x's will drop. Negative 1 minus negative 2 becomes plus 2, which is going to be 1. And then that's my remainder. So then to finish this, I would write plus 1 over x minus 2. So like this one would give me negative 2. And the problem is with that negative 2, I don't have a negative 2 as a remainder here. So that's a little goofy with that technique. This technique's a little goofy with the remainder kind of piece. We have one more. Yeah, we have one more. This one. Then we're done. Yeah, one more. Why? What's wrong with 5? You think it's shorter. You don't want to do that one that way. Trust me. This one's going to be better with synthetic. So we're going to, you just got to trust me. Okay. All right, so let's finish this up one more time. So if I have x and I want to make an x cubed, what do I need? Yes, so x squared, correct. Multiply down. X squared times x is x cubed. Negative 1 times x squared is negative x squared. Something weird happens here.
They both cancel out.
Yes. So when I subtract, they both cancel out. So therefore, I'm going to bring down both of these pieces. That's the only time, Paloma, I'll ever do that. So whenever you get a 0 remainder, you always want to have 2 pieces. So that's why I'm going to bring them both down. So I brought down the x plus 8 because already this is a 0. Okay, now, what do I need to multiply x by to make x? 1. So this is a plus 1. Multiply down, we'll get 1x and negative 1. And then we're going to subtract. Be careful, we're going to have 8 minus negative 1, which is going to make positive 9. That's my remainder, so plus, because it's a positive remainder, 9. And then what should go in the denominator? X minus 1. Okay, so this is long division. Give it a shot. I'll show you synthetic division on Monday.